Hello, ladies and gentlemen. It's Mr. Robeson here. Today we are working on statistics and we are trying to find probabilities using normal distributions besides just the special cases when we can use the empirical rule. All right, so the empirical rule is good, but it doesn't always work. So the empirical rule only worked when we got like whole number or like exact whole number standard deviations above or below the mean. All right, so what happens if we get like half a standard deviation or 0.7 of a standard deviation? Then what? Well, the empirical rule doesn't work anymore. Luckily, there's a way we can do this on our calculator. All right, and what we use is called the normal CDF. All right, so it has to do with the normal function and the graph of the normal curve that looks, something like this, whatever. All right, it has a certain mean. All right, and what we do is we say, okay, we have some sort of lower endpoint and we have some sort of upper endpoint, and we want to know the area or the probability in between those two, which would be the area of this section. All right, so what we do is we go to our calculator, we press second, and then we press the vars button. It's right next to clear. It brings us to something called the distribution menu, D-I-S-T-R. And then we go to number 2, all right, normal CDF. All right, and when we go to that, it either brings us this menu or it brings us to something that looks like just this, and it's like you can just type in the numbers and put commas after each one, that's fine, and then close the parentheses at the end, that works too. All right, but if you have the calculator, it'll do this. Some versions of the app will do this. Some versions of the app, you just type in the numbers. But it's just putting the numbers in the same order. So it'll ask you for a lower bound, then an upper bound, and then a mean and a standard deviation. All right, so no matter what you've got, you can just put in all those numbers and just press enter a couple times. So you go to paste, and then it'll take you back to the home screen. And here, I'll show you some examples. All right, so suppose the mean weight of adult golden retrievers is 70 pounds with a standard deviation of 6 pounds, and weights are normally distributed. So we've got a normal distribution with a mean of 70 and a standard deviation of 6. What's the probability of a dog weighing between 75 and 85 pounds? So that's not just a whole number of standard deviations. So like if we go up by 1 standard deviation, that's 76, not 75. All right, so what's happening is we've got this normal curve for the weights of our dogs, and it should still be above the axis, but oh well. 70 is right in the middle. 75 would be somewhere up here. And then 85 would be somewhere even farther up, like there. And then we want to know what's this little section in here. So the way we find that is we go to normal CDF. We put in our lower bound as the bottom number here, 75. We put in our upper bound as the top number here, 85. We put in our mean of 70, and we put in our standard deviation of 6. So let's go ahead and take a look at the calculator and do that. So on second distribution, so second vars, number 2, we've got 75 to 85 with a mean of 70 and a standard deviation of 6. And we get, see how it brings us back here. So if you have just one of the other apps, you just type in the numbers. You type 75, 85, 70, 6, close parentheses. I don't even think you have to close it, but it's lower and then upper and then mean and then standard deviation just in that order. So the order is important. And there's our answer, 0.196. So that would be like 19.6%. All right, but we can leave it as a decimal. That's perfectly fine. So this little area here is 0.196. All right, let's try another one. What's probably a dog weighing between 60 and 80 pounds? All right, so let's just take a sketch at a normal curve. I do suggest drawing these on your homework. So let's see, 70 is right in the middle. 60 would be somewhere down here. 80 would be somewhere up here. And we want to know between those two. All right, so we're working with a normal curve, so we go to normal CDF. Our lower bound, the lower number here is 60. Our upper bound, the higher number here, the end point of our section here is 80. Our mean is still 70. Our standard deviation is still 6. All right, so second distribution, normal CDF, number 2. Let's see, we're going from 60 to 80. The other numbers are staying the same, so we don't have to type them in again. And there we go, 0.904. Or 90.4%. All right, but the decimal's fine. You can just write the decimal, that's fine. And those are some cute puppies. All right, the other example we had the other day, so suppose the mean time for a mile run is 8.4 minutes with a standard deviation of 1.2 and times are normally distributed. So we've got a normal distribution with a mean of 8.4 and a standard deviation of 1.2. What is probability that someone will run a mile faster than 7 minutes? All right, so faster means less than, and when we're working with running, or we're working with times. So 8.4 would be right here in the middle. 7 would be somewhere down below it, and faster than that would be less time, so that would be down here. Now we don't have a lower endpoint, it just keeps going. So when we go to our normal CDF, we just pick a really low number. So like, what's the fastest anybody could possibly run? 0. I mean, it seems kind of ridiculous that someone could run it in 0, but sure. If you wanted to use a negative number, that would be fine too. Our upper bound though would be this 7, because that's the top of this colored in section we just drew. Our mean is going to be the 8.4, and our standard deviation is going to be the 1.2. All right, so we go to our normal CDF. Some of you might be wondering, what do we need the empirical rule for? Well, you probably don't anymore. You can do this on all of the problems, and you don't have to do the empirical rule anymore. In fact, we could derive the empirical rule using this stuff if we wanted to. And there's our answer, 0.1216, or just basically 0.12. So 12% of the data would be less than 7. Next one, what's the probability someone will run a mile slower than 9 minutes? All right, well, let's draw out our curve here. 8.4 in the middle. 9 would be maybe right there. Slower means a higher time, bigger numbers, like 10 minutes, 11 minutes, 12 minutes, and so on. All right, so if we want to find the area of that section, which is exactly the probability we're looking for, the lower bound would be the 9 where it starts, and the upper bound would be something big. It's like 1,000, 10,000, whatever. Our mean would still be the 8.4. Our standard deviation is still going to be the 1.2. And we just go back to our calculator, second distribution, normal CDF. And we're going from 9 on up to something big. So just put a bunch of zeros there. 8.4, 1.2 stay the same. And there we go, 0.308. 08, or 30.8%. Right? So this area here is 0.308. All right, now we can also derive the empirical rule. So remember, we could just go one standard deviation up and one standard deviation down. So let's see how that works real quick. And the easiest way to do that is just, let's see, we'll go -1 to 1 with a mean of 0 and a standard deviation of 1. And the empirical rule says if we go up and down one standard deviation, we should get 68%. There's 0.68. All right, what about 2 standard deviations? It said that we should get 95% if we go 2. There's our 95%. And for 3, so we got -3 to 3, and we get 99.7%. All right, so there's our empirical rule. It just comes from this normal distribution. All right, so that's it for this. That's it for normal probabilities. So check out your homework.